This video is going to walk through both questions 5 and 6 from our periodic function activity because both of them are sort of doing the same thing. We're being given one period of a function, and then we're basically asked to continue the pattern using this idea of, well, periods repeat. And so for me, what I like to do is I like to think of my period in different sort of noticeable chunks when it comes to the graph. So obviously there's the point you start at, and then I notice I have a line here till I get all the way down. And then, sort of another point here. And so every point that I'm marking on the graph, I want to figure out where it would be in the next cycle. So this first point is going to be right where my function begins. So that just continues on. And if I notice to get to this second point here, the x has increased by 2 and we've gone down 6. So if I go over 2 and down 6, now I have my second point. And then 2 over on a constant. And now here's the big one. I go over 1, 2, 3, 4. So 1, 2, 3, 4. And I'm going to go up 3 plus 7, 10. And then, and there's my next point. And then I go down 2 to the right 2. And now I go to the right 2 and up 1, 2, 3, 4, 5, 6, 7, 8 to my maximum. And then we go 2 over and down to sort of our ending point. And then it's just a matter of connecting the lines. And I'm going to use a little line tool to help me make this a little easier. And understand that, yours might not be quite perfect, but it's the general idea, and you should see a pattern. And you could go through and you could notice, okay, this point matches up exactly with this point, and this point matches up exactly with that point. You can sort of find those key points that match up. And I can do that, before, and I would repeat and do the exact same thing after. It's a little different, working backwards. So here, this is now this point, and we're going back to and up to that maximum. And then we're going to go back to and down to 5. And then we go back to and up to. And now we're going to go, down all the way to -3 and back 4, 2 of the constant, and then back up to 3. And so I'm sort of, I'm working backwards this time, but it's the same idea. And I can use sort of my line tool to connect again. And ta-da! I have 2 periods of I have 3 periods now drawn of my sort of periodic function. And I wasn't asked to find any of the key features of it. It was just sort of, can we continue and complete the cycle? All right, so with a table, it's even a little simpler, I find, because I'm given one period. So my period goes from 5 to 20. And this is the pattern, which means it's going to start again immediately following. So first off, we want to see what my x is counting by. So I'm counting by 5s here. So I'm going to assume that we're going to keep counting by 5. So my next number in my table is going to be 5 more, which is 25. And then this would be 30, 35, and 40. And then the pattern is going to be exactly the same here. So at 5, we were at 8. So at 25, we're at 8. And then we'll be at 2, then 14, and then 10. And so we have a period here of 20, just, in case you were wondering. And then I can work backwards. So this would be 0, -5, -10, -15. And the pattern just works backwards. So now instead of starting at 8, we're sort of starting on the far right end, that 10. And so 10. And then we have 14 and 2 and 8. And you can double check, did the period work? Look from here to here, we have a difference of 20. So check, my period's still the same. And that would be sort of filling in the period, filling in the table to create our periodic function. If you check out the CYU, you'll get some more practice with these types of problems, along with some other problems that maybe are a little more challenging than what we've seen in the activity. So make sure to check it out.